I didn't see you there. Of course, never mind, I'm not going to say what I was going to say. Anyway, section 6.3, multiplication and division of polynomial expressions. In other words, we're going to actually do some more reducing. You like that term, right? Right? Don't you? The other thing that you need to remember is factor, factor, factor. One of the most important things that I keep telling you over and over and over again. But hopefully some of you are going to remember it. When we're dealing with this, what I want to do is, I'm not going to literally multiply 6 times 14 and get 84 and then get this 70 plus 56 and get these big gigantic numbers. I'm going to go ahead and just factor. So I factor the 6 into 2 times 3 and the 14 into 2 times 7. Factor the 7 into 7. And 18 is 2 times 3 times 3. Why do I do that? Because then I can cancel out this one, I can cancel out this one, I can cancel out this one, and the answer is 2/3. I would have gotten that with this 84 over whatever that was, but why do all that work? So keep that in mind. So here's another example from this chapter. The original problem is 8x cubed over 27y to the 8th times 9y cubed over 12x squared. First of all, I can rearrange it because of the property of multiplication that says that's commutative, right? The order that you multiply doesn't matter. 2 times 3, 3 times 2, same thing. So that's what I did here, is I went ahead and I took the 8 and the 9 and I put them together. And then the x cubed and y cubed. Down below, I got the 27 times the 12 and x squared y to the 8. If you want to do it the hard way, you do this. You go 9 times 8 is 72, x squared, and 27 times 12 is 324. And then you got to worry about, okay, now what will factor out of those? Why do all that work when you can just do it right up front? And here it is, right up front. Take a look at this. 8 is 2 times 4. 9 is 3 times 3. I had x squared down below, so I'm going to factor this into x to the second times x, y to the third. That's y to the 8th, so this will stay as y to the third. Down below, I factored first the 12 into 3 times 4. 27 is 3 times 3 times 3. And x squared. Y to the 8th, I factored into y to the third, y to the 5th, because then that is there. And so what can I do with that? I can literally cancel out some 1s. That's a 1. That's a 1. That's a 1. X squared over x squared, that's a 1. Y to the third over y to the third is a 1. What does that leave on top? 2 times x. On the bottom it leaves 3 times 3, 9. X is gone, y to the 5th. And we are out of here. Easy? I hope so. Somebody said easy peasy, but I never liked that phrase, so I'm not going to say it. So here's another example. This time is division. That's the section, right? Multiplication to division. So the first thing I want to do is, I don't like division. None of you like division. We're going to change it to multiplication. How do we do that? All of you said it at the same time. Excellent. I didn't listen, but so I'm going to take the reciprocal, right? The reciprocal. See, you like that? Reciprocal of this and multiply instead. What am I going to do next, though? I'm going to look at this, and I hope all of you are paying attention and you can recognize this by now. This is, what? Difference of perfect squares. This is the sum of cubes. Not sure if this is anything, I'm not going to look at it. But what I'm going to do again is I'm going to factor, factor, factor. So the first thing I'm going to do is I'm going to use red and factor this one. Difference of squares, x plus y times x minus y. We're going to actually just extend it out. Here I've got a common x squared, so I've got x squared times x minus y. Interesting. This is x cubed. This is sum of cubes, so that's going to factor as x plus y times x squared minus xy plus y squared. Hopefully you remember that. Sum of cubes, difference of cubes. There's a pattern that you can follow to factor it like that. 1, 2, 3, done. You're out of there. Now we're going to try to factor this. Here's the trick. If you've gotten all the easy ones out of the way, you start looking at this, you know that you're going to have an x and another x. You also know you're going to have a y and a y. How are you going to get a negative here? Well, these both have to be negative. Is that going to work? Sure. How did I know for sure to kind of deal with that? Well, I had an x minus y on top, so I'm going to figure, hey, maybe it's a factor. So I could have started just by putting one and figure out the other one. Now what we do next is what? Cancel out what? Yes, cancel out the 7s. There is no 7s. How about canceling out the 1s? That's a 1. That is a 1. X plus y over x plus y. That leaves x squared over x squared minus xy plus y squared. And that is division of polynomial expressions. Thank you very much. Section 6.3. Over and out.